ഹലോ കുട്ടികളെ, നിങ്ങൾ ഹാപ്പി ആണല്ലോ അല്ലേ? ക്ലാസ്സൊക്കെ കാണാറുണ്ടാവുമെന്ന് വിചാരിക്കുന്നു. ഇന്ന് നമ്മൾ ചെയ്യാൻ പോകുന്നത് സർക്കുലേഷൻ ആൻഡ് ഫ്ലക്സ്. സർക്കുലേഷൻ ആൻഡ് ഫ്ലക്സ് ഓഫ് എ ഫ്ലൂയിഡ്. വർക്ക് ഡൺ പോലെ തന്നെയാണ് ഈ സർക്കുലേഷനും ഫ്ലക്സും. ദേ ആർ ഗിവൻ ബൈ ലൈൻ ഇൻ്റഗ്രൽസ്. സോ സപ്പോസ് ഫസ്റ്റ് നമുക്ക് ഫ്ലോ ഡിഫൈൻ ചെയ്യാം. ഫ്ലോൻ്റെ ഒരു സ്പെഷ്യൽ കേസ് ആയിട്ടാണ് ഈ സർക്കുലേഷൻ വരിക. ഓക്കെ, സോ വാട്ട് ഈസ് മെൻ ബൈ ഫ്ലോ? നമുക്ക് ഫോഴ്സ് ഫീൽഡിന് പകരം സപ്പോസ് വി ഹാവ് ദി വെലോസിറ്റി field of a fluid flowing through a region in space. Suppose vector F equal to mi plus mj plus pk represents the velocity field of a fluid. Fluid means it may be water, it may be a liquid, or it may be a gas. Flowing through a region in space. Region in space. So this is velocity field. So it's a vector. So you have the space, x-axis, y-axis, z-axis, and suppose that the fluid flows like this. So the velocity vector at this point is this, at this point is this. I will use a different color. So this is vector F at this point, and this is vector F at this point, and so on. Okay. Then the flow along the curve. Which curve? Suppose you have a parameterized curve in the space, in the domain of F. So suppose that this is the parameterized curve C. Then the flow, this is what we are going to define. The flow along the curve C from t equal to a to t equal to b, from t equal to a to t equal to b. So what are a and b? These are the endpoints of the interval over which the curve C is parameterized. So C is given by the parameterization R of t, where R of t is x of t I plus y of t j plus z of t k. X of t comma അങ്ങനെയും എഴുതാം, y of t comma z of t. This is the parameterization of C. The flow along the curve C from t equal to a to t equal to b is given by flow equal to integral a to b f dot t ds, where s is the arc length parameter. Okay, this is also the same as integral a to b f dot dr, d vector r. This is the same as work done if f is a force field. So flow is the same as work done, formula is the same, but physically there is a bit difference. That's it. Computation is exactly the same. Now we will do an example. A fluid flowing with velocity, a fluid is flowing with the velocity capital F equal to xi plus yj plus zk. That means capital M of x comma y comma z is x, n of x comma y comma z is y, and p of x comma y comma z is z. Find the flow along the helix r of t equal to cos t vector I. What is helix? Helix, I think you have studied in previous semester or even in this semester also. So helix is cos t vector I plus sin t vector j plus t vector k. 0 less than or equal to t less than or equal to 2 pi. Oh, let us use pi by 2. Whatever, doesn't matter. Pi by 2. So answer. So flow equal to integral 0 to pi by 2 f dot t ds so I have to find out vector t. This is also the same as integral 0 to pi by 2 f dot dr. Why is this? This is because t is dr by ds. Vector t equal to dr by ds. Therefore, dr is tds. Okay. Therefore, we have to find out dr. This is also the same as integral 0 to pi by 2, 0 to pi by 2, f dot dr is dx vector I plus dy vector j plus dz vector k what I can do is I can divide by dt throughout. So dt divided by dt divided by dt, then multiply by dt. Okay. This is also, this equal to is same as this equal to. So I have to find dx by dt. So what is dx by, so this is x of t. X of t is cos t, r of t is x of t, y of t, z of t. Y of t is sin t and z of t is t. Okay. So how do I do this? F along the helix. What is f? What is f? Xi plus yj plus zk. So what is f along the helix? F along the helix is, instead of x I have to use cos t. So cos t vector I plus y is sin t. Sin t vector j plus z is t. T vector k. Okay. Dot product with dx by dt we have to find. That means this is precisely dr by dt. This quantity is precisely dr by dt. So let us find dr by dt. So dr by dt equal to, what is r? Cos t vector I plus sin t vector j plus t vector k. So dr by dt is minus sin t vector I plus cos t vector j plus vector k. Okay. Therefore flow equal to integral 0 to pi by 2 f along the helix. What is f? F is xi plus yj plus zk. This thing. So f along the helix is, instead of x I have to use x of t, which is cos t. Cos t vector I plus sin t vector j plus t vector k, that is f along the helix. Cos t vector I plus sin t vector j plus t vector k. This is f along the helix. Dot product with dr by dt. So what is dr by dt? Minus sin t vector I plus cos t vector j plus vector k dt. Okay. So now how do you take dot product? Integral 0 to pi by 2 cos t into minus sin t. So minus sin t cos t or minus cos t sin t plus sin t cos t plus t into 1. So t times dt. This and this cancel. So t square by 2 between the limits 0 to pi by 2. So this is 1 by 2 into pi square by 4. So it is pi square by 8. Hope you understood. Answer is correct, I think. If there is a mistake, please let me know. Now definition. If C is a closed curve, then flow is called circulation. So circulation is equal to integral over closed curve. This C is closed, therefore to denote that C is a closed curve, I will use this notation like this. This arrow indicates that C is traversed counterclockwise. F dot T ds. We will do another example. Find the circulation of circulation means you are given a closed curve. The field vector F equal to x minus y vector I plus xj. There is no set component, so this is a field in the plane. Around the circle, r of t equal to cos t vector I plus sin t vector j. Zero less than or equal to t less than or equal to 2 pi. So you have this circle. In the xy plane, x-axis, y-axis, and you can plot f at different points. Take some sample points and plot. You will get an idea how it will look like. Directly we cannot say how it looks like. So circulation is equal to integral over C. I can put a sign like this. If dot T ds. This is also the same as integral 0 to 2 pi f dot dr by dt dt. Okay. So let us find dr by dt. Dr by dt equal to what is r? Cos ti plus sin tj. So dr by dt is minus sin t vector I plus cos t vector j. Therefore circulation equal to integral 0 to 2 pi f along the curve. What is f along the curve? What is f? X minus y times vector I. So f along the curve is x of t minus y of t times vector I plus x of t vector j. Okay. But what is x of t? It is cos t. So y of t is sin t. So cos t minus sin t times vector I plus what is f? X minus y times vector I plus x times vector j. F along C I have to compute. So in the second component I have to take x of t times vector j. But what is x of t? It is cos t. So cos t times vector j. Cos t times vector j dot product with dr by dt is minus sin t vector I plus cos t vector j times dt. This is equal to integral 0 to 2 pi. So component wise multiplication and addition. So cos t minus sin t into minus sin t. So what I will get? Minus cos t sin t plus sine square t. Then what? Then this cos t into cos t. So plus cos square t dt. Alright. This is 1. So integral 0 to 2 pi. And what is this? 2 sin t cos t is sin 2t. So this quantity is minus sin 2t divided by 2, right? Plus 1 dt. So what you will get? Um, 1 by 2 into sine. Integral of sine is minus cos. So integral of minus sine is cos. Cos 2t divided by 2 plus t between the limits 0 to 2 pi. So what I will get? What is cos 2 into 2 pi? So what is cos 4 pi? Cos 4 pi is 1, right? So 1 by 4 plus 2 pi. Now what is cos 0? Cos in the lower limit, cos 0 is 1 again. So it is again 1 by 4. So this 1 by 4, this 1 by 4 cancel, and the answer is 2 pi. That's it. Thank you.